Starts with the sun, 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 starts with the sun. You know it's straight, starts with the sun. Starts with the sun, oh yeah. Photons come down and hit the photosystem too. Electrons get excited and go bumping up a level. But photolysis comes in and donates 2 electrons. See, the water gets split from the photons from the sun. Oxygen goes away and comes to all of us. So those 2 electrons do redox reactions from acceptor to acceptor, all along the way making ATP like ka-ching, ka-ching, ka-ching. Then at photosystem 1, the cycle starts again, ending this time at a final electron acceptor. This makes NADPH from NADP. Where did the H come from? Photolysis! Yeah, it all takes place in the thylakoid membrane, so that's the end of the light-dependent reactions, but might I add that the accessory pigments are pretty rad. Now we got NADPH and ATP, and it all started with the sun. Don't need the sun, 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 don't need the sun. You know it's straight, don't need the sun. Let's take some CO2 and we'll turn it into sugar. Add it to a biscuit with some RUBP. Make 6 intermediates, then 12 PGA. Take the carbon for a lift and make a pyramid. This takes a lot of energy, but now you got PGAL. 2 separate to form a glucose while the rest continue on. A little bit more energy, and you got RUBP. The cycle starts again, and where does that glucose go? To the mitochondria, to cellular RS, or it can be stored, made into a wall, bonded with another glucose for transport. It's made in the stroma, in the chloroplast. That's only in plant cells, because plants are the best. I nom 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 the plants right there.
Every day I do RS, breaking glucose down into ATP. Every day I do RS, glycolysis is how it starts, breaking glucose down into ATP. Every day I do RS, glycolysis is how it starts, breaking glucose down into ATP. Every day I do RS, glycolysis is how it starts, breaking glucose down into ATP. Every day I do RS, breaking glucose down into pyruvic acid, and your net production, 2 ATP into NADH. If there is no oxygen in the cell, it makes ethanol and CO2 gas. But in an animal it's different. Lactic acid hurts the body, but if there is O2, then it goes into aerobic. Next we mix the acid with some coenzyme A. Then the acetyl-CoA is ready for the Krebs cycle. Hey! Citric acid, alpha glycutarate, succinate, and we got some energy now. Oxaloacetate, adds acetyl-CoA, citric acid, and the cycle starts again. Breaking carbon-carbon bonds, 6 NADH and 2 FADH2. Breaking carbon-carbon bonds forms 2 ATP, 6 NADH and 2 FADH2. Breaking carbon-carbon bonds forms 2 ATP. This is made in the chloroplast, then gets sent to the vacuole to be stored. Granules look like pancakes, they're green, the best. Glucose goes to the mitochondria to make ATP. Yes! Krebs cycles in the matrix, forming energy molecules that go to the cristae and then get transformed into ATP through EAs. Makes a byproduct of H2O. I checked to see how much ATP I made today. That FADH2 made 2 ATPs. Hey! And the NADH, man, it'll make 83. But I'll take that ATP and use it every day like yes.